There are three terms that aren't often used to talk about when you're talking about official statisticians, and they are innovative, strategic, and outward-looking. Right. No mai haere mai, my name's Andrew Spall, and it's my great honour and privilege to introduce you tonight to our speaker for this third Ihaka lecture, and that speaker is Peter Ellis. And those words actually ring true for Peter in his entire career, which is one of the reasons we've got him here talking tonight, because he's talking about innovating official statistics in a way that makes them much more accessible while still maintaining the high quality and the standards that we require from the official statistics system. Peter's actually had a long and varied career in applied statistics, but if you look at a strong theme in all his work, it's about realising the value of those official statistics. Because data, even official statistics, are worth nothing unless they are used. So you can see from Peter's work, even quite early on, is about extracting value, making data more accessible, creating standard systems for producing standard products, using open source tools that pretty much anybody can be an end user of. And that's what official statistics are about. They're producing standard things in standard ways that people know the meaning of. But the thing is that until quite recently, most official statistics had a very limited audience, right? And what Peter's work has done right throughout his career, and you can read a bit more about him in the bio for this third lecture, has actually been to increase that audience. And it's increasing the audience not in just terms of a passive audience, but in terms of an audience who can actually engage with the data, do things with the data, and do that in ways that means that they're no longer just a passive recipient at the end of a data pipeline. And in creating those data pipelines that are new and accessible, he's actually making the entire system much more efficient. So in his latest career move, which is the Director of Statistics for Development Division at the Pacific Community, or South Pacific Community in New Caledonia, he's already made a difference in the ways that Pacific official statistics are done, not just within SPC, but right across the Pacific region. And one of the great things is a lot of that work has been based on R. So it's my honour and privilege to welcome to the home of R, Peter Ellis, providing a talk about making R work in government. Peter.
Thank you very much. Thank you very much for that great introduction, and it's an enormous pleasure and privilege for me to be here at the birthplace of R, fidgeting with my electronic equipment, and to have a chance to talk in a way that might be perhaps a little bit different to some of the other Ihaka lectures I looked at previous years or the previous ones in this session, because I'm very much going to be talking about R in an organisational way, in an institutional sort of context. And one of the first things that I learned when I became a manager in the public sector was the importance of managing stakeholder expectations. In fact, there's whole courses that teach people this is all about what program and project management is. It's basically managing those expectations. So I need to sort of start by maybe setting out some things I'm going to be able to talk about today. This isn't, and I think most people will be quite relieved to hear this isn't going to be one of those talks aimed at senior leaders in the public sector about the 7 ways AI is going to transform their department. So probably no one's going to be surprised or disappointed that I'm not going to talk about that. But it's also not going to be a talk that's got lots of interesting Flash R code and flash effects and you know, there's going to be maybe a few little things like that. But basically, really, this is about the difficulties that there can be in making R work for government, and a little bit about how we can overcome some of those. And basically, you know, I have nothing to offer but Git, peer review, tests, and toil. So it's also a bit of a personal story. I would have liked to have stood up and given some in-depth, comprehensive research about the uptake of R in government departments around the world and so on. I haven't done that. That's not my job. I'm not able to do that. I have experience in a number of countries in doing this, and so I'm very much going to be talking about what I've seen, things that I've led or when I've been able to advise other organisations that have seemed to work. And so if I start a little bit about my personal story, I first got involved really in statistics back in the 1990s when I was working on performance information and evaluation for the Australian aid program. And my motivation was I was sick of losing arguments to economists. And so we'd be talking about, does this program work or does aid work? And eventually someone would put a regression equation with all these Greek letters on it, and I had no idea what it meant. So I need to learn this language. I didn't want to do an economics degree, but I thought if I studied statistics and econometrics, that would be like the back door to that. And it worked quite well. I stopped losing those arguments. I didn't do much applied statistics in that actual role, but like I learned a lot. We used S+ in those days. That was in Australia. I didn't even know of the existence of R. S+ was a great tool. It's based on S, same as R is. Expensive though. I paid $3,000 for my copy. And then at some point, for reasons that are surprisingly interesting but not really relevant to this, I left Australia and I left aid and I ended up in New Zealand. And there's a picture of me with my beloved Tararuas in Wellington from that period. On the left, we've got a tool that's not made in R, but it's at the end of a pipeline which involved lots and lots of R and was part of a data transformation of all sorts when I was at the New Zealand Ministry of Business, Innovation and Employment. And that was when I first got to use R because I found myself in charge of a statistics team. We needed to upskill in learning statistics. We realised that meant we needed to upskill people in the tool that they were going to use. They had a bit of SPSS, a bit of SAS, a whole lot of Excel. We systematically evaluated Stata, SPSS, SAS, and the newcomer R. And in fact, briefly we chose Stata before we decided that R was going to be the tool, basically on the grounds of its stronger data visualization capabilities. But these are some of the things which we worried about at that time. So this was 13 years ago, right, 2011. No corporate support. People said R's got this steep learning curve. There's a lack of learning materials. It's got this 32-bit thing going on. You can't have data. I can't remember, was it 1 gigabyte, 4 gigabytes? It wasn't very large before your workspace all crashed and can't handle large data. Now for the reasons in the dark blue on the right, which range from the existence of firms who are cashing in and delivering things through to the arrival of R 3.0, which was a big moment in 2013, and multiple ways of doing parallel processing, and we've got lovely smooth connections to databases, like reasons which in my recent lifetime, were posed as reasons for not using R, and now almost laughable. I particularly laugh at the one about the steep learning curve, the lack of learning materials, when there's an ocean of learning materials on R in ways that dwarf anything else in any other statistical package. Sort of back to my history. I had brief stints at the Social Investment Agency, Stats NZ, and I ended up in consulting. I was chief data scientist for a management consultancy called nuanced Group. What we're seeing on the screen here is some of the marketing materials, the propaganda from that group, skiting about Dawn, the data assets warehouse for NAS, which we built extensively with R, drew data from all sorts of places, made a SQL Server database with all of this harmonized data which we could use. It gave us massive competitive advantage over our competitors, the big four consultancy firms mainly, in dealing with public sector departments who are interested in things like skills, education, training, policy, and basically because we made the effort of using R to combine these divergent data sources, put it in a database, and then we had like a head start which we calculated was worth about 5 or 10 consultant days at the beginning of each project, because we could start using this database, producing graphics like this from day one, impress the clients. And now this is my current job. Bottom left is literally over the road from my office. I walk in, lovely half-hour walk, go for a swim in the World Heritage Lagoon, and then start doing statistics and stuff. Very nice. Other pictures are of my team doing training in our work, helping national stats officers run surveys, censuses, merchandise trade data, things of that sort. And we use R a little bit. And so like on the screen now, these are maps which are drawing on data on the Sustainable Development Goals in our Pacific Data Hub database. It's accessible by an API. There's R plugins to pull the data out. We've written a function that turns into these nice choropleth maps by the EEZs, and it's the sort of thing which you can all automate. And it's very much the sort of things we're talking about saying we've got all this data in this database. How do we make it easy to present to people so that you can produce a map like this in 1 or 2 lines of code rather than in a couple of hundred, when you deal with things like the problem that most maps you see are, not centered in the Pacific and all that sort of boring stuff you want to settle once and be done with. So, that was me. What's the problem here? So, analytics in government is often in a little bit of a mess. And the reasons why, well, first, the issues are often enormous in scope. They're as big as the whole social, economic, environmental issues of the country. The people you've got who are trying to solve those issues have been voted in. They've got 3 or 4 years to do things. They're in a real hurry. They're used to having things work out the way they tell them. Yet the data is often poor. Data from the National Stats Agency is usually very good, but it doesn't cover anywhere near the things that the ministers and people want to know. In particular, they want to know what works. That's a difficult statistical inference and causality problem, and yet they want to know today. Of course I want to know today. If I want to know tomorrow, I'd ask about it tomorrow, wouldn't I? The managers who are trying to manage these teams often don't really know what good looks like. If you're lucky, they studied statistics themselves 20 years ago when the tools were all different, the processes were different, and even our understanding of causality was actually taught very differently 20 years ago to how it's taught now. And partly because of this, and because of some particular features of the government sector, you have a whole hodgepodge of legacy systems. You've got a bit of SAS here, a little bit of Python here when someone once came in. Someone wrote a whole bunch of VBA, and then you've got spreadsheets and spreadsheets and spreadsheets and spreadsheets all linked to each other. And you've often got this lone genius in the corner. Don't disturb him, he's the only guy who knows how the spreadsheets work. And we need those spreadsheets to make some critical government function work, some vital statistic that needs to be reported, or some vital model which needs to be run every time a minister asks this question. This is the black box which answers this collection of linked spreadsheets, which tend to look a bit like this. And this is a real live example. And this is actually one of the better documented spreadsheets which you'll find in the government sector, because at least you'll see it's got various notes where people have written where they got their data from and so on. So this is a real life example where we had a very activist, very data concerned minister. He wanted to basically produce a report, an annual report was all he asked for, that would convey a sectoral view of the economy to business stakeholders and members of the public and so on. Get all this data from StatsNZ and elsewhere, put it in one spot. And he worked with the policy team to do this for more than a year, maybe for 18 months. Lots of iterations. What data do we need? Take it out, consult, many, many large PowerPoint packs of graphics and so on. Eventually reached the point, the minister says that this is okay. It's not as brilliant as I wanted, but it's okay. Just update all the data and we can publish it. And of course, you can imagine, right, with 20 spreadsheets like this, in 12 months in the public sector, the team had probably changed over completely. No one could remember who was there before. No one knew when they pasted the data in. If you were lucky, it would have said, oh yeah, this is GDP, without necessarily saying, is it quarterly GDP or annual, is it real, or which production basis is it, and things like that. So my team was given the job of updating that. We took it all out of spreadsheets. We rewrote it from scratch in R that could pull the data from the various sources. By this point in our maturity journey, we had a nice data warehouse that had most of the stats and Z data already in there, so we could write SQL and R to extract it, tie it together, join it together. And we actually hired GBO, who's a University of Auckland associated person, to write this shiny app, which is showing up in the top corner at the far end. And we produced the annual report, of course, but even better for the minister, every time data updated throughout the year, it will be automatically and regularly updated. And so this is sort of an example of the power of what you can do with something like R over something like the spreadsheets. Is something that's basically not possible, particularly for that updating sort of thing. And not knowing exactly what my audience is at the moment, I sort of thought, well, I should show sort of what the alternative looks like. And this is not actually scripts that do what that previous spreadsheet does, but it's doing very similar things. And those of you who know R, which I presume is actually a lot of you, will see that it's actually doing very simple things in this script here. It's like, in this case, it's using the read SDMX package to pull down some data from my own organization's specific data hub. It's going to the World Bank, and there's a special WDI package, the World Development Indicators package, that speaks to the API from the World Bank and gets that. A little bit of dplyr code to get me the latest year, do some joins, do some really basic calculations, do a plot. That's basically what that Excel monster collection of 20 Excel workbooks was doing. Except here it can be nice and linear. Even if you don't know R, you can actually go through and read it because it's pretty much straightforward English. A few comments is enough to do it. You can check it, you can peer review it, and most importantly, you can just hit source and it will update itself. So the basic requirements for this sort of work is that we want to be able to wrangle large amounts of data, many sources, often not under our control, which is different from businesses who are often working with data that's produced by their own business. In government, it's typically outside of your control. You want to be able to repeat it, update it, do it exactly the same basis. If your minister's going to stand up in Parliament and say, such and such makes us look good, whatever, on the basis of this number, you want to be absolutely sure that number's prepared on exactly the same basis as you prepared it 3 months ago. And you don't want to have had manual steps of someone copying and pasting into a spreadsheet on that. You need to be able to make statistical inferences on the fly all the time, and there's a surprising number of these happening in government. So they happen at obvious points where, like in evaluations, and you're saying, did this program work? Is the evidence show that something happened as a result of that, or how's it compared to the control group? Those sorts of things are obvious. There's lots of less obvious statistical inferences that are happening, such as, for example, in a typical validation process, you've forecast a time series and you compare what you actually got with that, and you want something to go bing if it's outside the prediction interval so that you know if something's gone wrong here, look at that. And you get lots of these little micro bits of inference that you want to do at scale in large amounts as part of your transformation and loading of data, moving from one spot to another, and imputation and small error estimation, all sorts of things. And of course, we need to do all of this fast and with inadequate resources. So R is perfect for this job. It's very safe. Handling these big, complex, multiple data sets is very efficient at it. And as you see, it's clearly better than, say, Stata or SPSS, which work okay with rectangles of data, but once you start getting complicated multiple data sources dealing with APIs, it's much harder. It's got a nice intuitive approach to rectangular data. It's got all the statistics you want in. It's got data visualization better than any other tool. I'm quite comfortable in saying that. These days it can do like your spatial statistics and your mapping beautifully as well. And it's got the ability, which of course, you know, we've heard in the last couple of weeks, to integrate your code and your output, whether it's tables and your graphics, into beautifully formatted reports in Quarto or Markdown and things of that sort. And as an example of the sort of superpower which R gives you in these sorts of environment is it's like, well, when you look at a thing like this and you want to show this to senior officials, decision makers, or ministers or something, they actually much prefer visuals like that. R is incomparable at producing a visual like that, because with a little bit of code like this, it's all there, it's repeatable. You can do things like, I want the software all ordered from one of the least features to one of the most. I want the features ordered with one's the most, software to the least. Put it all there, use my corporate colors, whack it on the screen, give it to the senior decision maker. Of course, you could do that in Excel, but it would actually be much harder and much harder to check. So, a little bit about the sorts of things that I've seen are being used in the public sector. And we'll start with official statistics, because that's one of the bigger areas, and it's an early starting area where people were using R more often, I think. And R is indeed a very good tool for official statistics. It's got all the survey functionality you'd want, and surveys are at the heart of many, many official statistics. Everything from your sampling design to the actual sample, and weighting, processing, analysis, it's all there. Lots of stuff on time series, which is the other thing which is very, very prominent in official statistics. So seasonal adjustment, all that sort of stuff, decompositions. And but also things like small area estimation, microsimulation, and so on. And so one thing, again, back in my New Zealand days that I used R for was to create the first set of territorial authority estimates of gross domestic product for New Zealand. And we did this by taking Stats NZ's regional GDP and basically disaggregating it further, using other things as a sort of a foundation for that, using small area estimation methods. And R, of course, is very good at that, because it's very good at combining all the data sources, as well as doing the actual statistical job in the end, and doing all the data visualizations on the way. So again, you know, we can produce these things. We could have Sankey charts and network charts. The network chart here is basically showing where people commute, you know, because we know where people live, but GDP has to be counted where you're actually producing stuff. That's what the P is. So we had to make corrections for where we thought people were commuting from. And on the left is just an illustration methodologically of how we take the GDP in one region and decompose it by industries and then further TAs. Great communication tool. So people who would not even care about the methodology for how you're doing your small area GDP can look at a chart like that on the left and say, oh yeah, I can see how construction in Taranaki is getting split up into its more detailed bits in the small areas that make up Taranaki, and they immediately got a visualization for how it is that we're doing that. Here's an example from another country. This is Vanuatu, very small country, relatively poor country. The stats office there is more in the vicinity of 50 or 60 people compared to many hundreds or more than 1,000 that you get in large countries, several thousand in Australia. But they're using R. In this case, they're using it for their merchandise trade statistics. They're taking data from Azakuta, which is a customs database that they use transactionally to record and pay your customs when you're importing something or exporting. They pull that data out. You know, they transform a bit with R, they stick it in a MySQL database, they pull it out again, they do validation, sorts of things I was talking about before, fill in gaps, go back to customs and ask what happened to the data, put it in another database, produce some nice R Markdown reports with various nice graphics and so on. It's like, so this is an example of its use in official statistics, but it's not doing much more than pulling data out of one database, transforming it a bit, making it wide, making it long, filling in some gaps, making some nice charts, plonking it into R Markdown. One thing which I think is neglected, isn't done enough, both in the public sector itself and in the consultancies that hang off the public sector, is cost-benefit analysis in R. R is beautifully positioned for this, and so are other tools like Python, to be honest. And that you can write a function that will do the take as your various inputs all of your assumptions and so on, and spit out as outputs your net present value, return on investment, whatever it is the government is interested in. Now, the vast majority of these cost-benefit analyses are done in Excel. And it's regarded as pretty good practice if you've got a low, a medium, and a high scenario with like some assumptions on that. You know, you're doing well if your consultants are doing that for you. With R, once you've written your function, you can then say, well, let's just give distributions to all of those assumptions. They can be dependent or independent, whatever you want, and run them through, and you get a distribution at the end for your net present values and so on. Even better, you can then put that function in Shiny app, give that to the policymaker, and say you can move the levers around yourself in the Shiny app, see what the impact is if you're wrong about how many people you think are going to use this new asset you're making. Very powerful tool, easier to do it in R than it is in Excel. 10 times the functionality. But the real superpower for R, I think, and the thing that makes it sellable to senior managers is the data visualization capabilities. And so what I'm showing on the screen here is like a speed run through I don't know, it's a 90-minute sort of webinar which I gave on polishing statistics to present results. And the graphics are all done in R, of course. The actual presentation you're looking at is a Quarto, so it's automated. You hit one button, the whole thing gets built. And you can see it's all done. You can't really tell the difference between that and the PowerPoint that I'm using tonight for my PowerPoint, because don't tell my design team, but we made it look exactly like that, so they'd think we are using the PowerPoint that we're meant to be using. And but it's brilliant as a training tool because you can, as you might be able to tell what's happening there, I'm iterating through various versions to improve a graphic, showing different things like adding annotations, using transformations, adding color and that sort of stuff. You can show people exactly how you're doing that, and this line of code is what did that. But you can also do it very efficiently, and you've got all the amazing power of R behind it. Great, okay, good. So we're sold. We're all here. This is Ihaka Lecture. We like R, unless you've just wandered in off the street. But, and there's the final thing, right? Shiny. Shiny changed the world when it came out because it suddenly meant that web application development could happen even if you didn't know how to write HTML and CSS and JavaScript and so on. It doesn't make the best web applications in the world, but it does way, way better than nothing, way, way better than just trying to pretend your Excel book is a dashboard, which is literally what people were doing 5-10 years ago. And I see Shiny as one of the three key sorts of options for people who want to make an interactive statistic graphic like this. You've got Power BI or Tableau or something, and these are very fast to make, and they're very good for relatively simple data structures and the data visualizations that fit into that. At the other extreme, you've got full stack web development, build it all from the ground up in HTML and JavaScript, and you can do anything and very complicated. Shiny is a brilliant compromise between the two, which often, not always, will meet the case as the tool. And what we've seen on the screen here is at least a dozen different Shiny apps that governments use that I took videos of at one point and whacked on the screen. Some of them my team did, some of them other countries, other places. Problem. Okay, we've got this great tool. It draws attention to other weaknesses that we've got. And the other weaknesses typically include moving the data around from one spot to another. And I say R is great at this, but actually, in the end, a lot of it is not going to be possible to be done with R. It's going to be done by people who are outside of your control. It's going to be done with data systems, which IT is running on their infrastructure with their tools. and it's maybe not being managed as well as it could. You've got access and control issues, and they work both ways. Too much access, like leaks, and not enough access, which is probably more common. The data's locked down. There's the data mining problem, where the great cartoon of someone sitting on the data saying, it's mine. It's just different to the statistical inference data mining problem, but probably just as serious. And then the other problems like quality control, teamwork, statistical inference. R, of course, is great. It's possibly the best tool, certainly an equal best tool for doing statistical inference of any sort, but it's only as good as the person who's driving it. So, luckily, there's a solution for all of this as well. And the solution basically comes from seeing R as not just your sole solution, but part of this ecosystem. So part of it is databases, two sorts. The organisation needs big, enterprise-wide data warehouses to support analytics. Unfortunately, these are big and they're expensive, and they're 6 or 7 digit, so hundreds of thousands, maybe even millions of dollars to build these things. But people need to invest in them if they want to take analytics seriously in a government department. But you also need quick and flexible spin-ups, whether they're little standalone databases like SQLite and DuckDB, or proper client server architecture like SQL Server or something. You're going to need this just to manage reasonably sized data in your analytics team. You're going to need Git for version control. You're going to need peer review. Reproducibility has to be built in as a fundamental principle. We need to improve the data governance, get around these problems of the data's not getting where it needs to be. And ultimately, we're going to need to connect better with the policy and the program clients. So these are all things that R is part of the solution for this, because R is great at getting data out of databases. It integrates nicely with Git. Obviously, it's good for reproducibility. It's not going to help you talking to your policy and program clients. So you've got this ecosystem that looks like this. So this is the Git peer review tests and toil diagram. And the toil really is actually, I use that because it sounded good rather than because it's actually particularly harder than any other way of doing things. Once you're in the habit of working in this sort of model, it works fine, and it's quick and it's easy. And you see we've got the idea of reusable data going into a warehouse, project-specific data, which is coming from all sorts of sources, and then you use R to join those two together. So you're extracting data from the warehouse, you're extracting data from the web or Excel that some clown gave you. You join it up together and you put it into your specific project database, which might be a SQLite thing, it might be SQL Server, it might just be half a dozen CSVs. The point is it's cleaned, it's tidied, it's analysis ready, and you can use it to create your definitive reports in whatever tools it is that you need to do your reports in, which might be like Shiny or Quarto, or it might be Power BI or something. And in my consulting time, we had enormous success with this pipeline, and then when we got to the end, we would put the data in a few different rectangles, import it into Power BI, and give the Power BI to the client who had the skills to do charts and stuff themselves. They didn't like the ones that we'd done. They didn't need to know how to use R and all this sort of stuff. We could update the data at any point we wanted with a one-button click, but the end result was in the tool that was appropriate to them, the level of sophistication that they had. And so this is all about really accepting R as being part of a broader toolkit, which includes things which here on the left are sort of, you might treat them as part of the data transformation of a data modernizing team. So it's databases, it's specialist statistical Bayesian tools, whether you're using JAGS or STAN, and it's Bash and Git, of course. But there's also these other things which, maybe not so like-minded, perhaps you might say, for R, but which people have to use because you are part of an institutional context. And I vividly remember the enterprise architect at a large New Zealand government agency telling me, well, we're not going to declare war on Excel because we'd lose. And that's very true. Like, I can tell you there is no way you are taking Excel out of government departments or private sector departments, and probably not even out of universities. It is there to stay. for a very small proportion of the things people use Excel for, it is actually the right tool. I think it's very good at financial models and things of that sort. Most things it's not the right tool for, but people are going to be using it for that anyway. And so we need to adjust for that. And sometimes it means people want the results in Excel. Very often it means you're going to get data in Excel that's provided. But PowerPoint, Word, Power BI, and that thing that looks like a whirling atom is, I think it's React. It's the JavaScript framework for building web applications. These are often going to be the right tools for various types of disseminations. So I'm using PowerPoint today. I sort of thought, can I get away with that? Yeah, I can, because it's the easiest, quickest way for me to present this sort of presentation. So not for a really intensive graphics one, like the one I showed the movie of. I do that in Quarto. But when I'm grabbing logos from all over the place, making dot points and things, PowerPoint is actually appropriate technology for that. And similarly with Word, government departments, people use Word. Since the revolution of a few years ago where people can be in the same document at once and editing it together, it's actually got an enormous advantage over even text-based things like Markdown and so on. You can't do that in a Markdown document that I'm aware of. And regardless of that, it's the tool that your policy people and your other colleagues are using. And so we need to have ways to hook R into Word, produce high-definition graphics and insert them automatically if we can, by hand if we can't. So, unfortunately, this does mean a lot of change, which the first aspect is that it means that everyone has to learn Git and SQL, not just R. And as I say out there, this is widely regarded as less fun. So people like R, oh, it's cool graphics or cool machine learning or something, right? I've never heard anyone say cool like that about Git. And even SQL is seen as a bit sort of daggy. Isn't that like a 40-year-old database language? Do I really need to learn that? I often tell people that it doesn't really matter, to be honest, what your first analytics language is. It could be R, Python, Julia, SAS even, right? So the second language you have to learn has to be SQL. And it's because databases are everywhere, and you can't do the statistical modeling unless you're getting the data out of the database. And you're not going to be efficient at moving data from one pipeline to another unless you understand how that works and how you understand a little bit about the server-client architecture and what to do on the server and what to bring down to the client and so on. And yes, there are great tools that are shortcuts like dbplyr and so on that let you give the illusion you're doing it all in R. Even those you'll do better with if you know some SQL. People have to actually change their work. They have to get peer reviewed. They have to use pull requests through Git in order to do it. And this sounds like more work, and everyone's already overworked, so there's a business process change there. And it needs to come from the top, because the managers need to be able to tell people, I know you're busy, I know you're overworked, we are going to build in extra time to this. So that's the plus side. The negative side is I'm not clearing your work until I know it's been peer reviewed, and the code's there in GitHub, and there's the pull request with the peer reviewer. IT need to invest. We've talked about that. It's expensive. The analytics teams need to be able to do that. And we need to sit in meetings and have data governance committees and talk to our clients and stakeholders. If we do change badly, we get some combination of these things in the grey here: confusion, anxiety, false starts, resistance, and frustration. And I've definitely had all of them. Sometimes I've had several or even all of them all at once in trying to do a change program. And I'm not an expert at trying to do change. I've had more and less successes at different places. And I think this is a nice little model. I'm not going to talk my way through it because, as I say, you can get a change management consultant to help you with that. Other than to reinforce the idea that if we are trying to get a government department to move from using Excel, from the lone Excel genius in the corner to the world of Git, peer review, and tests, and frequent integration and all that sort of stuff, we need to see it as a change project. We need to accept it's going to take 1 to 5 years. There's various things going to be required. And we need to convince people that errors are everywhere. And the main selling point for me with this model, the thing I described as the GET peer review tests and toil model, is that it is safe, it's got quality control. Because errors are the norm in analytics. They happen all the time. There's 100% of things have got errors in them. It's just a matter of finding as many of them as possible. But unlike a lot of the other errors in the public sector, they're both invisible and catastrophic. So catastrophic in the sense that, like, if you've got the sign wrong, everything is completely wrong. Invisible in the sense that you put it in front of the minister and it might have gone through a whole bunch of senior officials signing off before. None of them are going to know that you flipped around the columns the wrong way in the matrix at the beginning. The only way you're going to find that out is through rigorous peer review with things like GET and pull requests and so on. This makes it quite different to the other things happening in the government. If you put up a policy proposal and you forgot to cost it, which is as serious as getting the columns the wrong way around or something, a mid-level official, never mind a senior one, is going to say, hang on, there's no costings here. Go back and do it again. They're not going to notice that when you get it wrong in your analytics, which is why it's so critical we have the proper quality control things further upstream. And it's about persuading people that as skills develop, yes, it'll get worse before it gets better because you're building new systems. Some of this stuff is expensive, particularly the databases and stuff. Training is expensive. Taking people out of their jobs is expensive. Things get worse before it gets better. Eventually it will get better. And then suddenly, at some point, things become possible that were impossible before, like what I was showing with that sectors report, that not only could we update it at all, which was impossible in the Excel version, we could do it every day, or at least every day that there was new data coming out. And other things on the screen there about statistical modeling and inference. Upskilling in that helps not just in, yes, you know, I understand what statistical significance is in this evaluation. It also helps surprisingly a lot in your data management operations when you're creating small area estimations, doing computing, doing validation, all these sorts of things. So, a few specifics, and stick it out, folks, won't be long now. So some of the specifics of this stuff is a little bit abstract. One important thing is about getting some concrete wins quickly and using them to leverage whatever things you've got around, such as, in the public sector, it's often going to be something like ministerial enthusiasm. So this web app, which was actually built for us by Dragonfly Data Science, as I say, it was a classic full-stack web application at the end, not built in R, built in JavaScript. But there was lots of R building up to it, and the whole thing was only possible because of all the other things we were talking about. We did it because the minister was fanatic about getting more and better data in his hands, in the hands of his stakeholders. Once we'd done this, and it had become this huge success, it was much easier to get my senior managers, minister, anyone to support the next things that we're doing, even when it was like an expensive database project or something. Second thing that's really specific is about training, really, and I think sometimes there's a tendency in the public sector to see training as something like, okay, you have to get trained on issue X, we send everyone off the train, tick, it's done. I think of training more like, how do the All Blacks train, right? It's their job. They actually only play a few games a year. They spend, I don't know, I presume 40 hours a week hard on training one way or another, right? And that's the degree of professionalism and training and constant change which I expect out of an analytics team. And I quite like this old saying, I couldn't find out who originally said it, about education, where you say it's not about filling a bucket. You don't fill up people with knowledge and then send them off, they're done. It's about lighting a fire. So you light the fire, start it off, they're going to go away, they're going to self-learn, they're going to identify new things. And that's particularly critical in something like data science or statistics these days, where everything is changing. Certainly things I learned in the 1990s are, 30% of them are actually really useful. That's quite a high percentage, I would say. Most of the practical stuff is not. And even the bits with S+, there's now much better ways to do that with R than we could in S+ then. A few really practical things. You need to get IT on side. You need to make sure that they have packaged up for official installation. R and Git and a development environment. And I don't care if it's RStudio or VS Code or whatever. It's just got to be one of those things, and it's got to integrate Git. And you're going to need a database tool, whatever is the right one for the environment that your department's got. It's often going to be like SQL Server Management Studio, but departments that are going with other databases go with other databases. That's fine. It's really important to develop R packages that do things like fire up a PowerPoint template in the right template, got the right fonts, the right colors, make all of that easy, connections to your databases, things like that. And that's because it then makes it much easier for beginners, either people who are new to R altogether and are learning it, and there are always going to be some of those, or people who are R experts want to come in and start producing graphics straight away, or connecting to your data. You want to be able to teach those people with like, here's the one-liner, connect to our database and do whatever it is, and here's the one-liner to make the right PowerPoint, so they can get straight away in and be productive immediately. It is going to be necessary to re-engineer processes. There's going to need to be top-down control. When I was at NAUS, where I think we are scoring pretty highly on my desired level of maturity for analytics teams, as the chief data scientist, I could pick a project at random, go to the GitLab repository for that, clone it cleanly, then just arrange any proprietary data I had to get access to. And there should always be a file I can hit run, and I should be able to produce everything that's there for that project. And if I couldn't, I will be able to file issues in GitLab and say, you've got a problem. I go to the project director and say, you need to whip your people into shape because this thing's not reproducible. In order to do that, you need to have this culture that is going to happen at any moment. Peer review is a positive thing. We had a very high feedback culture, and people weren't protective about their stuff. They thought it was great that I would come and look at their repository and give them constructive suggestions. But that's going to be a big culture change in a lot of public sector departments. That's the roving spot check and get the data to the database. I think I've mentioned that, but it's worth saying multiple times. It's important. So, examples of small things. At my current work, we have an SPC style R package, which has got our colors and things like that. This is Sustainable Development Goals, and it's got there's an official UN color for each one, right? So before we put into this package, people would have to go to the UN site and say, oh, what's the color for the Life Below Water Sustainable Development Goal? Now we've got just a nice tibble that's in there. You build into your graphics, tell it ggplot to use that color, and it's done. Similarly, we've got a create SPC PPTX thing that will fire up a PowerPoint using the officer package. You can start putting your flex tables and your graphics straight into that. Because it's in a package, it all comes with documentation built in, ideal for beginners, ideal for induction. And things like this function I mentioned before, which is actually a personal one of mine. We haven't put it in the SPC package, but we will at some point for creating these choropleth maps. So it's the small things like this that add up to the bigger things that basically mean, well, what's it going to take to get R working in the public sector? And that's pretty much all that I had to say, except to remind you, this is what I had as the sneak preview, that basically analytics in government is difficult, it's often a mess, there's good reasons for that. It's not because they're clowns, it's because they've got immense problems, immense challenges, immense data needs and difficulties. R is a great tool for it, but it's not going to solve everything by itself. And it is possible to integrate it into a whole bunch of other tools that will actually basically make it possible to not just, oh, it's cool, I can use R to make some graphics and statistical modeling, but it can be part of a whole transformation of business processes, quality control, and the ability to do stuff. And that's really what I wanted to talk about. So thank you very much. And hopefully we've got a bit of time for questions. Questions and comments. Shall I just direct traffic, or? Could you repeat the question? I'll repeat the questions for the audience online.
You've been describing how brittle some of these data pipes are because of inexperienced users, spreadsheets, and so on. But R, compared to Stata, SAS, and even SPSS to an extent, is a constantly changing environment through its package and through its base distribution. So what are the challenges involved in dealing with that?
Yeah, no, that's a good question. It's true that R is, the question was if we're concerned about the brittleness of things like Excel and SPSS systems, how do we cope with the fact that R evolves so rapidly itself? And I would say that in two ways. First of all is that the way it evolves is actually pretty good for backwards compatibility. And much better, for example, than I would say with Python, where it's like, honestly, yeah, let's not go there. Whereas it's like, I've very rarely have I found something that used to work in R that no longer works. What does happen with the massive explosion of things is, oh, there's now a much better way of doing that than there used to be. So you've got this old code that does something in 100 lines that, now Hadley Wickham's made a way to do in 2 lines. So. And that's what feeds into the second part of my answer, which would be that most of these systems are only going to be healthy at all if people are constantly touching them and updating them anyway. And if something is created and then sits in the corner as a black box, it's not the way I like to run analytics, because very quickly you find a year later no one understands that. The consultants who built it have moved on. No one in the actual team understands it. And I've been in this situation many times, both with R and with SAS and other things. And you want people to be constantly tinkering with it, improving it, and so on. And if they're doing that, even as a relatively low level of maintenance with that, it keeps up with the explosion of functionality. But yeah, it's one of these things where it's manageable, but nothing makes it go away by magic. It's a great question, but that's part of what management's about. Question over here.
You touched on delivering results back in technologies that people are comfortable with. And the obvious one is delivering results back in Excel. And I wondered if you might comment on palatability of delivering results in a Shiny app or some JavaScript derivative versus Excel, and how that's changing.
Great. So the question was if I could comment on, I guess, the relative merits of delivering end results in Excel versus in Shiny. And I'll extend to that another key option, which is Power BI. I think they all have their place. Basically, you can put them in a continuum, Excel, Power BI, and Shiny, for presuming the end users are relatively unsophisticated, the amount of control which you're giving them over that. And so like, if they want an Excel, it's probably because they're going to do hideous Excel-ish things to it themselves afterwards, right? If what they want is just, I want the ability to make the graphics I want because I don't really trust you, Power BI is a brilliant alternative for that, because Power BI, unlike Excel, has got some disciplines in its data model behind it. It's got like, they exist as rectangles. You can see an entity relationship diagram like it's a database or something. And they can't muck it up by just scrambling the columns or sorting it or something. But they can make their own charts. They prefer their charts to yours. And it's actually a really great tool that I think much, much safer than Excel. So I think that if their purpose was they don't know how to code, but they want to be able to decide the charts they want themselves, I would go with Power BI. Shiny is great if you've got the chance to work with them to work out what it is that they want in terms of, say, my cost-benefit analysis things. It's usually pretty well defined. They want to see the net present value, the return on investment, and maybe a couple of forecasts out for the future. And they want to be able to change this, and this sort of assumption. Shiny is brilliant at doing that because you can specify all of that. You can code it up in an hour and hand it over. And it's absolutely perfect for that. So I guess my short answer is that I would generally, in fact, try to push people further to the right of that. So Shiny if they can. If that's not good enough, then go with Power BI. Only give them Excel if they're really sort of demanding it. and try to get that tool for them that gives them, that meets their needs in the best possible way. But Shiny is a brilliant way of delivering results, and we use it all the time in consulting. And in an analytics team, which is a bit like an internal consultant sometimes from the policy teams, we would use it quite a bit as well, because it's we have that little degree of control that you don't get when you just hand them over an Excel workbook. Great question. It's gentleman here, then over here. Yep. Can you speak up a bit? I'm a bit deaf.
Was around how government agencies might experience challenges with trade. One of the ones that's usually publicly scrutinised by media is the use of funding or budget towards things that may not directly make an impact to the public's lives. But obviously, when we're trying to make better decisions, we need better data, better visualizations to make these decisions with better evidence. What has your experience been with the specific challenge or constraint of navigating the beast that is government agencies with specifically around funding and use of taxpayer money while also balancing, I guess, media scrutiny?
Yeah. So the question was how, I guess, what's my experience with dealing with a public and media who are very focused on government not spending more money than they should, and the fact that some of these things cost money to do. Is that basically what the question was?
Essentially.
Yeah. And I think the key to that was in some of the early part of your question. Is like people are also focused, including the media, on the idea that you should have evidence in favour of what you're doing. Now, this is nowhere near as strong a current as I wish it was, and it's nowhere near as prominent in the political debate as I wish it was, but it is something that people will go back to, that they do want the evidence for that. Now, of course, they blanch when they see the price tag, particularly if the evidence is only going to be delivered by a national representative survey that costs $1 million or more, or by some of this big sort of IT's investments and so on. My personal experience has been that, I'm not going to say that I've always waved my hand and got the resources I needed, because that's not true, but it hasn't been as difficult as you might think. And in particular, in my time at MB, we had the tourism research and evaluation budget more or less at our disposal. And because tourism is such a big industry here and a powerful lobby, there was a strong sense that we needed to invest heavily in that. We had $3 or $4 million a year we were spending on tourism data. By stopping one domestic survey, we saved like $500,000. We had that as basically money to play around with creating new data sources, which we did by buying credit card data. We used it to invest in databases. And then we leveraged those databases to get other things happening. And everyone was really happy because the tourism industry was happy because we knew more about tourism than ever before. The media were happy because they saw lovely, colourful charts and things. And yeah, and we were basically, there was money there was savings that could be made when it would be done. So one more from this gentleman.
We actually hit time.
Oh, we hit time, okay.
Yeah, so unfortunately we've run out of time. It's been my honour and privilege to be Peter's host tonight. In fact, we haven't finished, we're now going out for dinner, so the struggle is real. But Peter has actually come in from New Caledonia for this, which involved him coming through Sydney. So it's been a long day.
Oh, it was a couple of days ago.
Oh, was it? That was a long day. And then has to wait a little while before he can get back. But this has been a really interesting and enlightening experience in understanding the application of applied statistics in diverse environments, especially where sometimes the skills that we learn at university might need a little bit of supplementation once we're out there in the workforce. So thank you very much for giving us a real world picture of what it's like to be an official statistician and using the resources to create the stories that various audiences, including those with resources like ministers, actually want. Thank you very much.
Thank you.